7-3, similar triangles. All right, for similar triangles, we have a couple theorems that allow us to go through this a little bit faster than the work that we did yesterday. So yesterday, if you look back at number 2, in order to see if two polygons or two shapes are similar, we had to go through all this work of comparing all the sides, making sure all the sides are the same, and we had to make sure all the angles were the same, right? Okay? Samaya, put your phone away. Don't try to hide it, you goof. Hey, turn your phone away. All right, so rather than doing all of this work, there's a way to kind of go through that faster. If we think back to chapter 4 with triangles, triangles get some special properties with theorems. So think back to chapter 4 if you have your notes. And we have these congruent triangle theorems. Kind of get a hint here with these top parts, side, side, side. What does AAS stand for? Angle, angle, side. What were the other ones? Good. Not side, side, angle, because that's that word that we don't like saying in math. Angle. Yep, we got angle, angle, side. We have side, side, side. What were our other ones? Good. Side, angle, side. And angle, side, angle. Good. Nice job. And we had a hypotenuse. Like, Abdurshid, can you go to your assigned seat? Can you go to your assigned seat? So that you can see the board. Thank you. All right. So, today we have similar properties, but they're for similar triangles, which is different because it's not congruent. They're going to be proportional. So you have that sheet that Mr. Klon passed out. You can go ahead and glue that in right at the top there, in the center. And then Abdiaziz, you can have a seat at your seat without charges. All right, so get that glued in. So glue should be out. You should be gluing this in. If you have not glued it in yet, you're just sitting there looking at the board and you don't have this glued in. Let's get going. Go. Share that glue, pass it around. All right, so we have 3 theorems for this one. Hi. We're gluing this in. We're gluing this in. Is that not glue? Why don't you say anything? Okay, glue. All right, so we have 3 theorems. We have SSS, AA, SAS. What do we think SSS stands for? Good. Side, side, side. Good. What might AA stand for when we talk about triangles? Angle. Angle. 2 angles. What about SAS? Good. Side, angle, side. So it's very similar to our congruent theorems that we've already had. We're just going to now be doing it with similarity with proportions. Proportions is a hard word to say some days. All right, so we're going to start with SSS. How many S's are there? 3. So when we talk about a triangle, how many sides are there? 3. So for this first one, it's all 3 corresponding what? What are we talking about specifically? Sides. All 3 corresponding sides are, and then we're going to say proportional. Proportional. So they're not congruent, they're going to be proportional as we work through. All right, if you want to grab some colored pencils, you can. I'm going to be labeling with some colors. I'm going to use purple, orange, and light blue, I guess. Just kidding, light green. That's what I got. So if you want to grab some colored pencils, you can. We're going to do this example on the bottom. So I'm going to move down to the bottom here. All right, so as I look at this, I want to know if these 2 triangles are similar. And when I look at these, the first thing I need to do is notice what information am I given. Am I given any sides? Am I given any angles? What do I know? Salifah, put away your phone. Abdir Rashid, put away your phone. Put away your phone. Are you? Okay. All right, so as we look at this, we're going to, what parts do they label? What is this 8, 6, 4, 9, 12, 6? What do those represent? Sides. Amazing. Thank you, Ifra, for talking today. I appreciate it. And answering questions. All right, so as we look at the sides, we need to decide which sides match with which ones. Okay, and it might be a little tricky to figure out which ones go with which. One way to think about it is thinking least to greatest. Our smallest side should match the smallest side. Okay, so what's my smallest side up here? Good, the 4, the CE. So this 4 should match which one down here? 6, good. All right, think about this. Remember with proportional, it's like we're scaling. We're making something bigger or smaller. When I take a family picture with my family, who do you think is the shortest person in my family? Me. Yep. Okay. If we make that picture bigger, we make it like take up the whole wall. Who's still the shortest person in the family? You. Me. It doesn't matter if we make the picture bigger or smaller. In the picture, I'm the shortest unless we use Photoshop. So we're going to start by taking that 4 and that 6 and comparing them. So we're going to do 4 over 6. So those are the 2 sides we're going to start with comparing. All right, let's take our middle numbers and compare those. So what other numbers would go with what? 6, CD, would go with 9. Good, those are our middle numbers. Am I going to write 6 over 9 or 9 over 6? Why 6 over 9? Because how did we write our first ratio? Yeah, we started with that top triangle, and then we wrote the bottom triangle.
Meeting with the principal, some more party, but not absent.
For Hamsi? Okay, thank you. All right, and then what's our last one that we need to compare? 8 and 12. All right, so our next step is to actually see if these are equal. If they're not equal, then our answer is, are they similar? No. If they're all equal and we show that all three are equal, we can just say, yep, they're similar. We don't need to know those angle measurements. So I'm going to use my Desmos calculator. That way I can just put in all my answers. 4 divided by 6. And then I can hit that enter button. 6 divided by 9. Enter. 8 divided by 12. And they all have to be exactly the same. Are they all exactly the same? Yeah, they're all 0.6 repeating. Good. So are these similar? Yep, because they all equal the same. So our answer is yes, they're similar. And then let's write our similarity statement. Remember, a similarity statement, it matters our order. The first triangle, we can say it in any order we want. So triangle, how do we want to say this first one, this top one? CED or CDE? What did you say, Afra? CED is similar to triangle. Now we need to match that down here with this one. So C is where the 6 and 4 come together. So what letter would match the C down in this bottom one? You have your color code. Mine is purple and orange. It's where purple and orange come together meet C. So what's going to come together to meet there? U. So C actually matches U because they're in the same spots. They're where our two smallest parts come together. Now we went to CE. CE was the 4. It was the smallest amount. So do I want to go UT or US? Good. US and then end at T. All right. How are we feeling? Making sense so far? Okay, so how is this easier than yesterday's work where we did this one? What part is missing? Because to me, this still feels like a lot of work. Answers are fine, yeah, and they were all equal. We did that fraction part. What was our first step we needed to do yesterday in number 2? The angles. We needed to make sure angles are congruent. Do we know that the angles are congruent in these two? Does it tell us that angle S is congruent to angle E? No, it doesn't. So we don't need that extra information. We don't need to mark those angles. We just need to check those sides. All right, here we go with the next one. AA. AA is how many parts are we going to be comparing? 2. 2 corresponding what? Angles. And when we talk about angles, are angles proportional or are angles congruent? Congruent, yeah. Good, congruent. So we just need 2 corresponding angles that are congruent for AA. All right, so as I take a look down here at the bottom, which angles do we have that are marked on our triangle here? Do we have 2 angles that are congruent? Which ones? Okay, T and K are congruent. How do we know? Good, they both have that 56. So angle T is congruent to angle K. Do we have another angle that's congruent? U and L? Do we know that U and L are congruent?
Think back to chapter 3. We talk about vertical angles. It tells us which angle are congruent.
So how are vertical angles, what's their relationship? How are they located? Are they next to, across, touching, not touching, vertical angles? Across, yeah. So where do we have two angles that are across from each other? Yeah, at that J. So I have this angle here that will be congruent to the angle across, right next to it. When we name those angles, I can't just say angle J because I won't know which one of those angles we'll be talking about. So if I name those angles, I need 3 letters. So how would I name this top angle J? Where would I have started at? Good. T, J is my middle, that's that vertex, and then up to U. Good. Very nice. T, J, U is congruent to angle LKJ. That would be talking about the 56. Could start at L, but where do I want to go in the middle? J. So L, J, K. So do we have 2 angles that are congruent? Yeah, we don't even have to check the sides. We don't need to know the sides. We don't need to do any of those fractions. Our answer just instantly is, are they similar? Yep. We do need to write out our similarity statement, which is similar to how we write a congruent statement. First triangle, doesn't matter the order we put the letters in. You get to choose. It's up to us. Although, what do you want our first triangle to be? U, then what? Right, UTJ or UJT? UTJ. Is similar. Remember, similar, we're just doing that squiggle. They're not exactly the same. They're not the same size. They're the same shape. To triangle. And now for our second one, we need to match. So what matches with U in this bottom triangle? Which angle? L. Okay, Aldo picked T next. So what's going to match with T on the other triangle? K. And then J matches with J. How are we feeling? Making sense? A little bit? You're probably like, why the heck are we doing this? I agree. Why the heck are we doing this? We're doing it. It's math. Equations. I don't know. This one's a silly unit to me. Similar because we have to make sure the things are the same. All right, last one. Last one for today, and then you get the rest of the time to get your homework done. We have SAS. So what does SAS stand for again? Good. Side, angle, side. So we're going to start with 2 corresponding sides. Two corresponding sides are proportional. They have that word proportional written for us, which is nice. And the included angles, included angles are congruent. So 2 corresponding sides are proportional, and the included angles are congruent. When we talk about including, what does it mean to be included? Yeah, like to be in, to be part of something. So when we talk about included, we want to look at where those sides are, and the included angle is the one that's like between the sides. Those sides come together. All right, last example. All right, so first thing when we look at these problems is we want to identify what are we given. So what information do we see here? What's labeled? Sides, yeah, that 10, 14, 35, 49 sides. How many sides of a triangle are labeled here? 2. So can I just go straight to saying it's side, side, side? No, because we don't have that third side. So we have 2 sides. Is there an angle that I know is congruent? Yeah. Which one? E. Yeah, those angles at E. What do we call those angles that are across from each other? Good. Vertical angles, and vertical angles are congruent. So we have 2 sides and we have an angle. So we can go ahead and start comparing these. We need to decide which numbers are going to compare with which other numbers here. So which one do we want to start with? Do you guys want to do 35 or 49? Okay, 49. In that top triangle, is 49 the bigger length or the smaller length? Bigger. So I want to compare the bigger length with the bigger length down here. What is that 49 going to match with in that bottom triangle? Matches with 14. In our brains, we might have wanted to match it with that 10 and think about it being like flipped over, but it actually matches with that 14. So 49 over 14. And I want to just double check that it works with one other side, with that included side. Since I started with 49 on top, which side do I want to start with on top here, the 35 or the 10? Good, the 35, because the 49 and the 35 come from the same shape. So 35 will go with 10.
Does it matter if it flips?
Nope, you'll get the same answer. So that's a good question. Mr. Kwan just asked. Last year, he's looking at last year's notes. Last year, we started with a 14. Trying to find my last year's notes. We did this. We did 14 over 49 and 10 over 35. But here we get the same answer. It ends up being 0.285. But when we do this, are we going to get 0.285? No, because 49 is bigger than 14, so we should get a number bigger than 1. We get 3.5. But now as I compare that to the next number, what's our next fraction? 35 over 10. Do I get matching answers here? Yeah, so these are equal. So just what our scale factor is, it's just going to tell us which one we started at and which one we're going to. Is going to tell you what that number means. But you should get matching. So it's okay to flip them. You could have 14 over 49, but then we'd have to have 10 over 35. Get the same answer. So our answer is yes, these work. All right, remember it's that included angle. It's where the orange and my purple come together. They touch at that green L. So for our similarity statement, first triangle doesn't matter the order. Okay, pick however we want it to look. Ansel, what do you want our first triangle to be? Yeah, you. DEC is similar to triangle. So for the second part here, I need to figure out what matches with D. D is at the end of that 49. And 49 matched with 14. So what would match with D? N, M, or E? M, yeah, M. So then went D to E, so we want to go M to E, and then end up at N. Triangle men. Sounds strong. No? Okay. Cool. Miss Merrill, we're so happy you're our teacher. Thanks, guys. I'm happy too.